Determine the formal charge on atoms in H2CO. So the first thing I need to do is draw my Lewis structure because formal charge depends on knowing how atoms are connected to one another. So I'm going to first count the number of valence electrons I have in the molecule. For hydrogen, I have 2 hydrogen atoms, each with 1 valence, plus 4 for the carbon, plus 6 for the oxygen. And so I have a total of 12 electrons in my structure. I see that carbon is going to be a central atom. Hydrogen always has to be terminal atoms. And oxygen will be a terminal atom because carbon is less electronegative than oxygen. So I've filled out my skeletal structure. I've used up 6 of my electrons. I have 6 electrons remaining. So I'm going to fill in the octet on my terminal atoms. So it's really only the oxygen I have to worry about. The hydrogen only wants 2 electrons, so it's perfectly fine there. Now I see that while my oxygen has an octet, my carbon does not, and so I need to move electrons from that oxygen atom into forming a double bond here between the carbon and the oxygen. So I'm going to redraw this structure. So I have an oxygen now with only 2 lone pairs of electrons with a double bond to carbon and single bonds to hydrogen. Now I've used up my 12 electrons and I have everybody with an octet. Well, for hydrogen it has a duet. So now that gives me the Lewis structure for H2CO, and I can use that now to find the formal charges. So now I need to look at each atom to determine the formal charge on each of these atoms. So I'm going to start with my hydrogen atom. And what I look at is the number of electrons assigned to hydrogen in an isolated atom, which would just be 1 electron. I subtract the number of non-bonding electrons assigned to it in the Lewis structure, which is 0 in this case, and half of the bonding electrons. So it has 2 bonding electrons around it. I take half of that, and I see that I get a formal charge of 0 for my hydrogen. So we're going to put a little 0 there to record that. I notice that it's going to be the same for both hydrogens because they both have the same type of structure in this particular Lewis structure. Now I'm going to look at my carbon atom. It would have 4 electrons in the isolated atom. It has no non-bonding electrons, and it has 8 electrons around it, so I take half of 8, and that's going to give me a formal charge of 0 as well. Now we can look at the oxygen atom, and we see that in oxygen it has 6 electrons assigned to it in an isolated atom. We subtract off the number of non-bonding electrons assigned to it in the structure, which in this case is 4 because we have 2 pairs of non-bonding electrons, minus half of our bonding electrons, so we have 4 bonding, and I also get a formal charge of 0. And this is actually as good as it gets to have formal charges all of 0. Remember, we always want to get those values as close to 0 as possible, and we can't get any closer than this. And that just indicates that we have a very stable structure here.